Simulating frictional contact on solids has been a trending research direction in computer animation for many years. Yet, much less attention has been paid to adhesion, a closely related mechanism. We introduce a novel, incremental potential-based, variational method for animating the sticky interactions between elastoplastic solids. We model the adhesion in the normal and tangential directions independently. Our normal direction adhesion energy can be directly absorbed into the distance-based contact barrier, which is consistent with the classic RCC model from computational mechanics. A physically intuitive parameterization of the adhesion stiffness is also provided for user-friendly control of versatile behaviors. We also propose a smoothly clamped tangential adhesion model that can consistently capture the bonding and debonding process, which is also consistent with the RCC model. Directly incorporating the RCC model into the IPC framework introduces 6 parameters, while our variational model only exposes 2 parameters, which makes the setup more convenient without sacrificing efficiency and expressiveness. In this study, we demonstrate that various distance thresholds yield comparable adhesion behaviors. We compare our method with the constraint-based method. When larger time step sizes are used, a penetration artifact occurs in the LCP solver, causing the twisting knot to deviate from its central location and resulting in a distinct final pose. We perform 2 canonical tests on a scene with 2 initially stacked adhesive plates: the parallel pulling and the peeling. The force time plot clearly captures the bonding and debonding process, which is consistent with the classic RCC model. We validate our method with real-world experiments. When peeling towards the upper left direction, the tape progressively detaches the desk. When peeling towards the upper right direction, the detachment happens rapidly throughout the whole strip under large tension right after the right end travels just a short distance. Here we show more examples. We stick an elastic armadillo onto a pillar using 2 sticky tapes modeled with discrete elastic shells. As we peel the top tape off, we successfully capture the realistic slowly detaching effects. A bag containing 750 chips is sealed with adhesion. We show the process of pulling the bag slowly on the top until it is opened. Here, intricate frictional contacts between the chips are also realistically captured. Here we show an octocat captured by a sticky spider web. An envelope is sealed by sealing wax. We selectively model adhesion only between the meatballs and the sticky rice grains to cook a traditional Chinese dish. As we shake the container after dropping the meatball and rice, the rice uniformly covers the meatball. We construct a sushi machine with 5 stiff glass plates. Our adhesion model allows the sushi to stand still after removing the plates. Thanks for watching.